Hello friends, I am Priyanka Runmane. Welcome back to your channel Excellent Coaching Classes Goa. In the previous videos, we have learned few topics of real numbers like Euclid's Division Lemma, Euclid's Division Algorithm, Fundamental Theorem of Arithmetic, and how to find HCF and LCM. The link of the previous videos is given in the description box. Please go and check that out. Also, hit the bell icon to subscribe our channel for more such educating videos. So, today's topic is Real Numbers Part 3, in which we will study about irrational numbers. So, let's get started. So, we'll revisit irrational numbers. Now, what are irrational numbers? Irrational numbers are those numbers which are non-terminating and non-repeating. That means which will not terminate on division and which will not repeat its pattern while dividing. So, we'll learn more about it. Now, we'll do theorem 1.3, which says let P be a prime number if P divides A square, then P divides A, where A is a positive integer. So, we'll use this theorem in further proofs. We'll move on to next theorem, which is theorem 1.4, which says root 2 is irrational. Proof is, before starting the proof, I would like to tell you we will do all the proofs by the method of contradiction. So let's start that. Let us assume to the contrary that root 2 is rational. So if root 2 is rational, that means it is in the form of A upon B, where B is not equal to 0 and A and B are integers and A and B are also co-prime, which implies B root 2 is equal to A, as we have cross multiplied B over there. Now we'll square both sides. After squaring both sides, 2B square is equal to A square. Now B square is equal to A square upon 2. That means A square is divided by 2. Therefore, 2 divides A square, which implies 2 divides A as well by theorem 1.3. Let A is equals to 2C, and we'll substitute this value in equation 1 in this equation, which implies 2B square is equals to 2C whole square. After squaring this, we'll get 2B square is equal to 4C square. We'll send 4 over there. Now, you can see after sending 4 over there, we get 2B square upon 4 is equal to C square, which can be cancelled. Hence, we'll get B square upon 2 is equal to C square. Therefore, 2 divides B square, which implies 2 divides B by theorem 1.3. Since A and B has 2 as its common factor, but this contradicts the statement that A and B are co-prime, because co-prime are those numbers who has nothing common in between them and both the numbers are prime numbers. Therefore, our assumption was wrong that root 2 is rational, which implies root 2 is irrational, hence proved. Now let's move on to the next part, which is example 9, which says prove root 3 is irrational. Solution: let us assume to the contrary that root 3 is rational, which implies root 3 is equal to A upon B, where A and B are co-prime and B is not equal to 0 and A and B are integers, which implies root 3B is equal to A. Now we'll square both the sides. So root 3B whole square is equal to A square. After squaring them, we'll get 3B square is equal to A square, which implies B square is equals to A square upon 3. So 3 divides A square, which implies 3 divides A as well by theorem 1.3. Now, let A is equal to 3C and substitute in the equation 1. which implies b square is equal to 3c whole square upon 3. After squaring it, we'll get 9c square upon 3. And after cancellation, we get b square is equal to 3c square. Now we have cross multiplied 3 over here. So we get b square upon 3 is equal to c square. So 3 divides b square, which implies 3 divides b as well by theorem 1.3. Since a and b has 3 as its common factor, which contradicts the statement that a and b are co-prime. Therefore, our assumption was wrong that root 3 is rational. Therefore, root 3 is irrational. Hence, proved. So, the next question is, we'll be doing example. The next example says, which is example 10, show that 5 minus root 3 is irrational. The solution to it is, let us assume to the contrary that 5 minus root 3 is rational, which implies 5 minus root 3 is equal to a upon b, where a and b are integers and co-prime and b cannot be equal to 0. So, we'll send the root value over there and we'll bring all the other values on one side, which implies 5 minus a by b is equal to plus root 3. As we are sending root 3 over there, the sign would change to plus, and as we are bringing a by b over here, so its sign would change from plus to minus. Now, which implies 5b minus a upon b is equals to root 3, as we are taking LCM over here. After that, since 5b minus a upon b is rational as it is in the form of a upon b, therefore root 3 is also rational as it is equal to it. But this contradicts the fact that root 3 is irrational. Therefore, our assumption was wrong that 5 minus root 3 is rational. Therefore, 5 minus root 3 is irrational. Hence, example 11, show that 3 root 2 is irrational. Solution, let us assume to the contrary that 3 root 2 is rational, which implies 3 root 2 is equal to a upon b, where a and b are integers and co-prime and b is not equal to 0, which implies root 2 is equals to a upon 3b, as 3 would cross multiply over here. Since a upon 3b is rational, therefore root 2 is also rational, but this contradicts the fact that root 2 is irrational. Therefore, our assumption was wrong that 3 root 2 is rational, which implies 3 root 2 is irrational. Hence, proved. Let's move on to the exercise, which is 1.3. Question 1. Prove that root 5 is irrational. Solution. Let us assume to the contrary that root 5 is rational, which implies root 5 is equal to a upon b, where a and b are integers and co-prime and b is not equal to 0, which implies root 5b is equal to a. Squaring both sides, which implies root 5b whole square is equal to a square, which implies 5b square is equal to a square, which is my equation 1, which also implies b square is equal to a square upon 5, as 5 would cross multiply over here. Since 5 divides a square, which implies 5 divides a as well, by theorem 1.3. Let a is equals to 5c and substitute it in equation 1, which implies 5b square is equal to 5c whole square, which implies 5b square is equal to 25c square. Now 25 would cross multiply over there. We'll get 5b square upon 25 is equal to c square. After cancellation, we get b square upon 5 is equal to c square. Since 5 divides b square, which implies 5 divides b as well, by theorem 1.3. Since a and b has 5 as its common factor which contradicts the statement that A and B are co-prime. Therefore, our assumption was wrong that root 5 is rational, which implies root 5 is irrational, hence proved. Question 2. To prove 3 plus 2 root 5 is irrational. Solution. Let us assume to the contrary that 3 plus 2 root 5 is rational, which implies 3 plus 2 root 5 is equal to A by B, where A and B are integers and co-prime and B is not equal to 0, which implies 2 root 5 is equal to A upon B minus 3. As we are sending 3 to the other side, plus sign would change to minus, which implies 2 root 5 is equal to A minus 3B upon B. Here we have taken LCM. After that, we'll send 2 down by cross multiplication, which is root 5 is equal to A minus 3B upon 2B. Since A minus 3B upon 2B is rational, therefore root 5 is also rational. But this contradicts the fact that root 5 is irrational. Therefore, our assumption was wrong that 3 plus 2 root 5 is rational, which implies 3 plus 2 root 5 is irrational. For CBSE students, if in the exam it is asked to prove 3 plus 2 root 5 is irrational, then please check whether root 5 is given irrational or not. If it is given irrational, then you just have to do this procedure which I have just now shown. Otherwise, you have to first prove root 5 is irrational and then you have to prove in the second part that 3 plus 2 root 5 is irrational. Now question 3, which says prove that the following are irrationals. Number 1, 1 upon root 2. Solution is, let us assume to the contrary that 1 upon root 2 is rational, which implies 1 upon root 2 is equals to A upon B, where A and B are integers and co-prime, and B is also not equal to 0, which implies B upon A is equal to root 2, as we have cross multiplied them. Since B upon A is rational, therefore root 2 is also rational. But this contradicts the fact that root 2 is irrational. Therefore, our assumption was wrong that 1 upon root 2 is rational, which implies 1 upon root 2 is irrational, hence proved. Let's move on to the next part, which says us to prove 7 root 5 is irrational. Solution. Let us assume to the contrary that 7 root 5 is rational, which implies 7 root 5 is equal to A upon B, where A and B are integers and co-prime and B is not equal to 0, which implies root 5 is equal to A upon 7B, as we have cross multiplied 7 over here. Since A upon 7B is rational, therefore root 5 is also rational, but this contradicts the fact that root 5 is irrational. Therefore, our assumption was wrong that 7 root 5 is rational, which implies 7 root 5 is irrational, hence proved. Next part, which asks us to prove 6 plus root 2 is irrational. So solution, let us assume to the contrary that 6 plus root 2 is rational, which implies 6 plus root 2 is equals to A upon B, where A and B are integers and co-prime and B not equal to 0, which implies root 2 equal to A upon B minus 6, which implies root 2 is equals to A minus 6B upon B. Here we have taken LCM again. Since A minus 6B upon B is rational, therefore root 2 is also rational. But this contradicts the fact that root 2 is rational, therefore our assumption was wrong that 6 plus root 2 is rational, which implies 6 plus root 2 is irrational, hence proved. So guys, that's all for today. So friends, in the next video, we will learn about rational numbers and their decimal expansions. So stay tuned and thank you for watching. Friends, please hit the like button if you liked our video. Hit the share button to share it with your family and friends, and do not forget to subscribe if you have not subscribed our channel yet. Click the bell icon to stay updated for upcoming educating videos. Also, comment the topic which you want to see in the upcoming videos. So, until next time, keep learning. Bye-bye.